So I just wanted to go through homeolytic fission of a chlorine molecule. So if I draw out a chlorine molecule there, okay, you know that chlorine is in group 7. So each chlorine atom has 1, 2, 3, 4, 5, 6, 7. And then the other chlorine, I'm just going to draw with dots. 1, 2, 3, 4, 5, 6, 7 electrons in the outer shell. 1, 2, 3, 4, 5, 6, 7. Now, because chlorine is the same atom, then there's no difference in electronegativity. Okay, so there's going to be equal sharing of the electrons. Okay, now when you go to break that bond, there's two ways of breaking the bond. Fission implies breaking. Homeo implies the same. Okay, so you can break the bond where both atoms receive the same number of electrons. So for instance, one of the electrons will go back to this atom and then the other electron goes back to that atom. Single-headed arrows mean that you're showing the movement or the transfer of one electron, okay, because there's only the one single-headed arrow there. So this electron's going back to its original atom and this dot here is going back to its original atom. When the atoms break like that, you end up with 1, 2, 3, 4, 5, 6, 7, and you end up with the other chlorine atom having 1, 2, 3, 4, 5, 6, 7. So when you look at it, the molecule has split or broken up, and you end up now with 2 chlorine atoms, okay? So you've essentially just got back your atoms again. So these are neutral, okay? But they're very, very reactive. Why are they so reactive? Because look, they've got an unpaired electron. They have 7 electrons in their outer shell. These chlorine atoms will react with anything in order to gain another electron so that the configuration is then stable. And what we call these, which are really, really reactive with an unpaired electron, we call these free radicals. Okay? So that's if the atom receives the same number of electrons when you break the bond. Okay, and just rub that off now. And what about if it's heterolytic fission? So heterolytic, hetero implies different. Okay? So same situation again. I'm just going to redraw my chlorine molecule, 3, 4, 7, and the other chlorine atom has 1, 2, 3, 4, 5, 6, 7. Now, if I go to break this, and say, for instance, this chlorine atom receives both. See the way I'm drawing a double-headed arrow? So the 2 electrons there are going from the bond over here. So what do I get then when I redraw? I get 1, 2, 3, 4, 5, 6, 7. But this chlorine atom is also getting this electron, okay? And then the other instance then, I have 1, 2, 3, 4, 5, 6. This atom here isn't getting any. So that's how it's heterolytic. This atom receives 2 of the electrons from the shared bond. The other atom on the left isn't getting anything. So what do I end up with now? Well, this atom here has received an electron that never belonged to it. So it's gained an electron. So it's now a negatively charged ion. This atom on the left has lost an electron, so that's going to become a positively charged ions. Ions aren't as reactive as the free radicals because the electrons are all in pairs. Look, pairs, pairs, pairs. They don't have an unpaired electron, so not as reactive as the free radicals would be. Okay, so this chapter 23 is all about types of reactions, all right? And you firstly need to know about, breaking bonds so that the atoms can react with other atoms to form products, okay? So the alkanes, we're starting off talking about the reactions of the alkanes. And alkanes will undergo 2 types of reaction. They undergo combustion reactions that we talked about in thermochemistry last year in chapter 21. And they also undergo substitution reactions. So what we're going to be doing in the next lesson is talking about the mechanism by which a substitution reaction happens, okay? And a mechanism is just a step-by-step description of how the reaction takes place. Substitution is like substitution in a match. So what we're going to have is a molecule like methane, which is an alkane, and we're going to be reacting that with a chlorine. And what's going to happen is that one of the hydrogen atoms comes off and chlorine takes its place. So you end up then with chloromethane as one product, and the hydrogen that came off reacts with the other chlorine to make HCl. So hydrogen chloride and chloromethane are your products, and substitution means an atom comes off and it's replaced by another atom. Okay?